Alright, in this video we're going to be going over chapter 10.2, which is systems of linear equations and several variables. So a linear equation in n variables is an equation that can be put in the form of a1 x1 plus a2 x2 plus terms in between, and then I have an xn. So there's n variables in this equation, which is denoted by the subscripts, and it equals c. So our a1, a2 all the way to an and c are real numbers, and our x1 all the way to xn are the variables. So if we only have like 3 or 4 variables, we usually just use x, y, z, and w instead of our subscripts. And such equations are called linear because if we had 2 variables, a1x plus a2y equals c is the equation of a line. So for example, I have 6x1 minus 3x squared plus the square root of 5x3 equals 10, which is a linear equation because I have all my coefficients are constants, and then they're real numbers, and then my x's are the variables. So another example of a linear equation is like x plus y plus z equals 2w minus 1/2. So all the coefficients are real numbers and constants, and I have my variables. So nonlinear equations are like x squared plus 3y minus square root z equals 5. So I have a variable under the square root. So this isn't a linear equation, and also have an x squared. And then I have x1, x2 plus 6x3 equals negative 6. This also is a nonlinear equation because I have a product of variables. Okay, so in solving a linear equation, we have a form that's called triangular form, which means that the variable x doesn't appear in the second equation, and variables x and y don't appear in the third equation. So to see this definition played out, we have our system of linear equations. So I have x minus 2y minus z equals 1. I have negative x plus 3y plus 3z equals 4. And I have 2x minus 3y plus z equals 10. So in triangular form, basically, when we added equation 1 and equation 2, we were able to cancel the x, but I keep it in the first equation. So basically it's like, I'm going to add equation 1 to equation 2 and get a new equation 2. So I get x minus 2y minus z equals 1, and then I get y plus 2z equals 5. So my variable x doesn't appear in my second equation, and then if I subtracted, if I subtracted and I got my z by itself, so I got z equals 3, and basically that was just, I could cancel the y's because I get 2x, my x is canceled already from adding and subtracting, and then I was left with a z, and that is z equal to 3. And so in that equation, my x and y don't appear in the third equation, and so I just have z equals 3. So we'll go ahead and see how to do this in following examples. So I'm just going to take the same equation here, and that's going to be my example. So I have x minus 2y minus z equals 1, and I have y plus 2z equals 5, and z equals 3. So I'm going to back substitute. So I have my z equals 3, so I'm just going to go ahead and plug that into my second equation for z. So I have y plus 2 times 3 equals 5, so I get y equals negative 1. And then I'm going to back substitute that, my z and my y, into my first equation. So I get x minus 2 times -1 minus 3 equals 1. I get x equals 2. So my solution is 2, -1, 3. And you can plug those back in and see that they satisfy the system. Okay, so in order to change a system of linear equations to an equivalent system, so an equivalent system is a system that has the same solutions as the original system, we use the elimination method. So operations that yield an equivalent system is we add a non-zero multiple of one equation to another, we multiply an equation by a non-zero constant, or we interchange positions of two equations. So we have Gaussian elimination is using the above operations here to change the system to an equivalent triangular system. Then we use back substitution. So in adding a non-zero multiple of an equation to another, that's just like multiplying equations by a constant. And then basically you add or subtract the equations, and then you could just basically you replace an equation by whatever you added and subtracted, and then you can just undo the multiplication for that one equation that you had manipulated to add it or subtract to the other equation. So let's go ahead and see an example of this, and then hopefully it'll be clearer. And go ahead and go through this video pretty slow, just because it's a pretty difficult concept in my opinion. So I'm going to go ahead and solve this system using elimination. So I have x minus 2y plus 3z equals 1, x plus 2y minus z equals 13, and then 3x plus 2y minus 5z equals 3. Okay, so I labeled each as equation 1, equation 2, and equation 3. Okay, so I'm going to go ahead and look at equation 1 and equation 2. So I want to eliminate the x term from the second equation to change this. So I have x plus 2y minus z, which is my equation 2, equals 13. I have x minus 2y plus 3z equals 1, which is my equation 1. So I'm going to go ahead and keep my equation 2, but I'm going to multiply equation 1 by -1 to cancel my x term. And then that's going to give me my new equation 2. So if I multiply equation 1 by 1, I'm going to get, I'll do it like in purple. So I'm going to get negative x plus 2y minus 3z. So, and then I add these. So I get the x's cancel, 2y plus 2y is 4y, negative z plus negative 3z is negative 4z, 13 plus 1 is 12. So this is my new equation 2. So I put this as my new equation 2, and then I'm going to keep my equation 1 as it was before. So I'm not going to change it like how I changed it by multiplying by -1. I'm just going to keep it how it originally was. Just change equation 2. So I have x minus 2y plus 3z equals 1, 4y minus 4z equals 12, and 3x plus 2y minus 5z equals 3. So now, in order to get into triangular form, I also want x to be canceled from equation 3. So I'm going to eliminate x from the third equation. So by doing that, I'm going to basically do equation 3 plus -3 times equation 1 to get my new equation 3. So when I multiply by negative 3 to equation 1, that is negative 3x plus 6y minus 9z equals negative 3. And then I'm adding that to equation 3, which is 3x plus 2y minus 5z equals 3. And that's how I get my new equation 3. So my new equation 3 is 8y minus 14z equals 0. And then I keep my equation 2 and equation 1 the same. So we keep doing these steps. So now I also want to eliminate the y term from the third equation because I just want z in the third equation. So I do that by multiplying equation 2 by negative 2. And I add that to equation 3 and I get my new equation 3. And so I get negative 6z equals negative 24. And I leave my equation 2 the same. Okay, and so now in order to get my z by itself and my second equation's fine, I have it in triangular form now. I have x, y, and z in the first equation, y and z in the second, and just z in the third. So I'm just going to basically get the y and z terms by themselves. So I'm going to multiply the second equation by 1/4, and I get the new equation 2, just to cancel out the constants. So I get y minus z equals 3. I'm going to multiply equation 3 by negative 1/6 to cancel out the 6. So I'm just essentially dividing this by negative 6 and dividing each by 4. So I get z equals 4. So now I have a triangular form, I have z equals 4, and I could back substitute. So I know z equals 4 is one of my solutions. I'm going to substitute this into equation 2. So I get y minus 4 equals 3. So y equals 7. I back substitute this to my first equation. I get x minus 2 times 7 plus 3 times 4 equals 1. I get x equals 3. So my solution is 3, 7, 4. So basically the goal of this problem was to get just the z in the third equation. So I canceled out the x and the y from the third equation. Then I just wanted y and z in the second, so I canceled the x in that equation, and then basically my first equation stayed the same, and that's the triangular form. So the number of solutions of a linear system is a graph of a linear equation in 3 variables is like a plane in 3D space. So system of linear equations in 3 variables represents 3 planes in space. So 3 planes may intersect in a point, in a line, or not at all. Or all 3 planes may coincide and be the same plane. So the system is the same. The system could have one solution, no solution, or infinitely many solutions. So this one's the one solution. So the 3 planes, imagine 3 pieces of paper, and they could, like, if you cut them, they could go into each other. The system has one solution, so they just intersect all 3 at a point. The 3 planes intersect at more than one point. The system has infinitely many solutions. And so that is that the 3 planes basically they share a line, and then the line basically goes on forever. And so that is infinitely many solutions. And then also if the 3 planes are the exact same plane, that would also be infinite amount of solutions. And then the 3 planes could have no point in common at all. So yeah, 2 planes may intersect, but in order for there to be a solution, all 3 would have to intersect at the same point. And so that would be no solution. So again, a system with no solution is inconsistent, and a system with infinitely many solutions is dependent. And so we would know that there's no solution if we have a false equation after applying Gaussian elimination to the system. So let's go ahead and do that in this example. So I have a system with no solution, but we won't find that out until we solve it. So I have x plus 2y minus 2z equals 1. 2x plus 2y minus z equals 6, and 3x plus 4y minus 3z equals 5. So my goal is I want to eliminate the x term from the second equation and the third equation. So I go ahead and do this by, I have equation 2 plus negative 2 times equation 1, and that gives me a new equation 2, which is negative 2y plus 3z equals 4. And then to eliminate the x from my third equation, I have equation 3 plus negative 3x times equation 1 equals my new equation 3. So essentially, I could multiply any equation by the constant to get rid of my x's, basically. It doesn't have to be a certain equation. So I could have multiplied like equation 2 by some value to get rid of the x in equation 3. So it doesn't really matter. Whichever one works. Okay, so now I have negative 2y as my variable in my equation 3. So I have it in one variable. And that is supposed to be negative basically, let me see what that one was supposed to be. So I have x negative 2y plus 3z equals 2. Okay, and so now when I basically, I'm going to do equation 3 plus negative 1 times equation 2 equals my new equation 3, because I'm trying to eliminate the y term from the third equation. And I get negative 2y plus 3z equals 4. And then when I add the negative 1 times equation 2 to the third equation, I get 0 equals negative 2, which doesn't make sense. So that is no solution. Okay. And then a system with infinitely many solutions, I have x minus y plus 5z equals negative 2, 2x plus y plus 4z equals 2, and 2x plus 4y minus 2z equals 8. So I'm going to eliminate the x terms from the second equation and to the third equation. So I have equation 2 plus negative 2 times equation 1 equals my new equation 2. So that's 3y minus 6z equals 6. And then I have equation 3 plus negative 2 times equation 1 is my new equation 3. So my new equation 3 is 6y minus 12z equals 12. And then make sure you guys are doing, if you guys are getting confused, to actually do these calculations and see it for yourself. And then I eliminate the y term from the third equation. So I do equation 3 plus negative 2 times equation 2 is my new equation 3. And that's 0 equals 0. So my z has infinitely many solutions. So z can take on any value. So I'm going to solve for x and y in z. So I get 3y minus 6z equals 6. I'm going to get y by itself. And I get y equals 2z plus 2. And then I get x minus 2z plus 2, because I substitute the y, plus 5z equals negative 2. I get x equals negative 3z. Okay, so since z has infinitely many solutions, I'm basically going to write x and y in terms of z. And so I'm going to let z be any real number t, because z is my variable, and t is going to be just any real number. So my solution, I have x, y, and z. This is like my solution set. And I'm writing it vertically just to see it easier. and I get, so I have x equals negative 3t. And then my y was 2z plus 2. So z is just any real number t. So I have 2t plus 2. And that's because z is infinitely many solutions. Then I have z equals t. So my solution set is negative 3t, 2t plus 2, and t. So t is called a parameter. So in order to get a specific solution, because t can be any real number, we have to give a specific value to our parameter t. So here's some just various examples of parameter values and various infinite solutions. So I have infinitely many choices for parameter t, so the system has infinitely many solutions. Okay, so here's an applications problem. So I have Jason receives an inheritance of $50,000. His financial advisor suggests that he invests this in 3 mutual funds: a money market fund, a blue chip stock fund, and a high-tech stock fund. So the advisor estimates that the money market fund will return 5% over the next year, the blue chip fund 9%, and the high-tech fund 16%. Jason wants a total first-year return of $4,000. To avoid excessive risk, he decides to invest 3 times as much in the money market fund as the high-tech stock fund. How much should he invest in each fund? Okay, so our unknowns is the amount that he invests in each fund. So let x equals the amount invested in the money market fund, y is going to be the amount invested in the blue chip stock fund, and z is the amount invested in the high-tech stock fund. So I'm going to convert each fact that I see in the equation, in the word problem, into an equation. So the total amount invested is going to be $50,000. So the amount in each fund is going to add up to that amount. So I have x plus y plus z equals 50,000. Okay, and then the percents that I'm going to get in the return is going to be 0.05, because I'm going to get 5% in the money market fund, plus 0.09 times y is the blue chip, and 0.16% return in the high tech. And the total return is going to be $4,000. So that's going to be my return percentages times the amount that I invest, and I want it to be $4,000. And then I want my money market amount to be 3 times the high-tech amount. So in order, basically, since my money market is going to be greater than the high-tech stock fund, I would have to multiply 3 times the high-tech stock to get to the amount that I invested in the money market. So that's why it's x equals 3z. Okay, so I'm going to multiply the second equation by 100 to basically get rid of the decimals, and then rewrite the third equation so I have it, my variables lined up. This is the system, and I'm going to solve it using Gaussian elimination. And I subtract the 3z over to get it in the correct form. So I have equation 2 plus negative 5 times equation 1 is my new equation 2. And then that is 4y plus 11z equals 150,000. I'm going to do equation 3 plus negative 1 times equation 1 is my new equation 3. So my new equation 3 is negative y minus 4z equals negative 50,000. So my goal is I want to basically get one equation where I have just a z, and then another equation, my z and y, and then one of them just all the variables. So right now, I have 2 equations that have y and z. So I'm going to go ahead and get just z in equation 2. So I have equation 2 plus 4 times equation 3 is my new equation 2, which is negative 5z equals negative 50,000. So I'm just going to divide by -5 to both sides, and I get z equals 10,000. And then I divide by -1 in equation 3 to get y plus 4z equals 50,000. And I could actually just interchange equations. So I interchange equation 2 and 3, basically just flipping it down so I get my triangular form. I get x plus y plus z equals 50,000, y plus 4z equals 50,000, and z equals 100,000. So now I use back substitution. So I have my z is 10,000. I could plug that into my second equation, and I get y equals 10,000. And then I plug in my z and my y to my first equation. So I get x equals 30,000. So that's the money in the market fund. 10,000 is the money in the blue chip stock fund, and 10,000 is in the high tech stock fund that I'm investing. Okay, so that's it for this video. So I'll see you guys next time.